Hello guys, welcome once more to class online. I am Tutor Dami, and in this edition we shall be looking at Waec Physics 2015 question number 36 to 40, and we shall be dealing with questions that have to do with very sensitive areas in physics that many students find difficult. Now, one of such is, have you ever been at home before and one of your plug got damaged? Now, in this series we shall be talking about how to set up an electric plug, and we shall be opening it up so that when next you have a problem with a fuse at home or with a plug at home, you can easily remove it and set it up on your own. And we shall be looking at other aspects of physics that have to do with calculation, like resistivity and some other part of physics that you will learn a lot from. Now, don't forget that if you learn something from this video, click on like button. We have lots of content to share with you that will better help you understand physics. Now let's go to the question number 36. An electric generator rated 12 kilowatt, 12 kilovolts, distribute power through a cable of resistance 2 ohms. Calculate the power loss in the cable. Now, do you have any idea the formula for power? If you don't, I'm going to tell you. Now, this is the power formula. Electric power is always given by the formula IV, where I is my current, my V is my voltage. Just multiply the product of current and voltage is power, and that is the formula for electric power. However, it can be modified into I square R. It can take different shape, but the general formula is power is IV, which is current times voltage. However, it can come in different shapes, like I have I square V, I square R, and so on. Now, generally, we are told to find, the first thing to do in this question is to find the current, because of course we were not given current. Can you see that in the question there is no mention of current? So the first thing to do is to find current. Now, calculate the power loss in the cable. So power is equal to IV, right? Now find the I. I is therefore P over V. How did I get that? I just said the V beside the current here, I move the V from here under here. So the I current equals P over V. So my power is what? 12 kilowatts. I was given here 12 kilowatt for power over the voltage, which is 2 kilovolts. Okay, 12 over 2 is therefore 6 ampere. So the total power in this system of generator, is just 6 ampere. Power is equal to current times voltage. So if you divide if you have to find the current, you just divide the power by the voltage, and that is 12 over 2, and that's 6. So my current is 6 ampere, right? Now the next thing is to find the power loss, and then to find the power loss, you will use another formula of power, which is I square R. Okay, I told you that power can be IV and power can be I square R. So if you begin with IV, don't use IV again. Use I square R to find the loss power. So if this is the current 6 ampere, just to find the power loss, just say I square R. So put the current in 6 squared times the resistance, which is 2 ohms. Why is it called power loss? Because power loss is always by this formula. Do you know why? Because for it to lose power, that means a resistance to the flow of charge must have occurred. Okay, that means if charge is flowing through a circuit or through a wire, right? For the wire to lose some powers, then there must be resistance or opposition in that wire, and that's why I don't use IV to find power loss. I use I square R, because there must be resistance to be a loss. For it to be a loss, there must be resistance. So I square, the I is 6, that's the current is 6 squared, times the resistance is 20. 6 squared is 36, that's 6 times 6 times 20, and that will give me 720 watts. So the power loss is 720 watts, and that is the way to go, and that is the answer, making option C the correct answer for that question. Let's check out number 37. Which of the following statement is correct? When capacitors of different values are connected in series, what happens? When you connect capacitors in series, what happens? Capacitors in series means they are on a straight line, right? So you have capacitor 1, capacitor 2, capacitor 3 connected on a straight line. Okay, now that means what will happen? Which one will happen? Is it the same charge will flow through them? Is it true that the same charge will flow through them, or the same voltage appear across each capacitor, or different quantity of charge flow through them with voltage across them? Then different quantity of charge flow through them with the same voltage across them. Now generally we know that anything series has the same current, and anything parallel has the same voltage. That's a general rule. So current is the same for series, while voltage is the same for parallel. But what about charge? Now this question is talking about charge, It's talking about capacitors in series. What will happen to the charge and what will happen to the voltage? Now, if it is in series first, the voltage are not the same. You have to add the voltage. But what about the charge? The charge will be what? Let's check it out here. Now, capacitors in series. Capacitors in series each have the same charge, and that is the answer to the question. Any capacitor in series will have the same charge, just as they have the same current. So any series connection like this one here, in this place I have series connection. Okay, if I like the one I have here, I have Q, 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 Q. So the series connection is straight, it's always on a straight line. So if it is in series, the capacitors will be the same. Okay, so the capacitance will be the same, and that's what I have there. So I have the same. Then it says it each have the same charge. The charges will be the same. If there are capacitors in series, the charge will be the same, not the capacitor, but the charge will be the same. Just as the current of anything in series, current flowing through things in series are the same. Also, their capacitance their charge will also be the same. Current of anything flowing in series will be the same, just as the charge will be the same, except the voltage will not be the same. So now it will have different voltage like you have it here. Voltage V1 plus V2 plus V3 equals Q C1 V1 equals C2 V2 and C3 V3 and so on. So that is the law. Now generally, so we have that the same charge flow through them. Option A is the correct answer, because anything in series, just as the same current flow through them, the same charge flow through them. Number 38 now. Which of the following statement about a 3-pin plug is correct? Now, the brown wire is a live wire. The fuse is connected to the live wire. The earth is color blue. Now, generally, which one is correct? Now, for you to have a plug, if you have a plug, now many of us have TV at home, right? Some of the time, that part where you connect to the socket to bring in light is called the plug. Okay, that means the end of the wire of the TV connected to the socket is called the plug. Now, but once in a while, the plug can be damaged. That means the fuse in the plug can get bad. So now it has happened to me before that I have to change the plug. Like it's sparked and the substance that the plug head broke or something. It fell from my hand or something. Then I have to remove it and change it. So I have to remove the wire from the plug and buy a new plug head and then connect it back. And that was not difficult. Do you know why? Because I learned it in physics. And here it is now. When you bring in the wire, this is the wire coming in. The wire is 3-phase, and so it's 2-phase. That means it has a neutral and a live connection. Now look at this now. This one that is brown in color on the picture is the live wire, and this live wire will go to where the fuse is. Please don't forget, you might have to do this on your own next time. I will just unlock this nut, loosen it, then put the wire under it, then close it. Then also I will connect this earth. The earth is always green and yellow. It's always color green and yellow. It will go under the front part. It stays in the front. So the earth stays in the first, that's in the part that's at the front. While the live, that's the one that carries the charge. That's the red one or the brown one. The red or the brown wire goes to the fuse part. Then the neutral goes backward. Because why? Because the earth is placed between the neutral and the live, right? Always between the neutral and the live, because the two lines, live and neutral, must not touch. If they touch, there will be an explosion if there's current flowing through it. So they put the earth between them so that they will not touch. And you can see the setting. They are far from each other, neutral and live, so that they must not come in contact, so that there will be no explosion. So this is the arrangement. Now let's look at the option now. The first one says that the brown wire is live, and that's true. The brown wire is live. Then number 2 says the fuse is connected to the live wire. That's true. This is the fuse here. It's connected close to the live wire, and that's true. Option 3 says the earth is blue. The earth is not the blue one. The earth is the one in the middle. The earth does not carry any charge. It is just there for safety. So the purpose of the earth, the current flow in from the live and return from the neutral, right? But the earth is not carrying any charge. The earth is just there for safety. In case somebody gets shocked, the earth will save you. But if there is no earth connection in your system, it is going to shock that person to death. So the purpose of the earth is to collect the charge when it shock you from you and to send it to the earth so that you will be free from death. So the purpose of the earth is to save you. It is a safety device. So it is not only working, it is only waiting for the day somebody will behave stupid and the person will get shocked, and then the earth will save the person. So you must always make sure that every connection, everything you have at home have earth connection. It is for safety. So the wrong one is just that the earth is blue, but 1 and 2 are the correct answer. So the option C is going to be the correct answer. Number 39. The symbol illustrated above is that of a resistor, right? Now, which resistor is this? Is it the one which absorbs light, or the one which emits light, or which absorbs heat to function properly, or whose resistance is light dependent? You can see that word, light dependent. Does that word ring any bell to you? Light dependent. It is actually a kind of something, right? Have you heard about anything called LDR, light dependent resistor? Now that is just the answer. This is a light dependent resistor. That is LDR, right? Light dependent resistor. And you can see the light. This is a resistor, but it is a way of drawing it. This is just a diagram. Now, if you are a person who want to study electrical engineering or anything that has to do with electricity, okay, you will need to be able to read electrical manual. And in the manual, they don't write English. They use symbols, and they don't always describe what the symbol means. So if a panel has problem and you are a NEPA for example, or you are an engineer, if you look at the diagram of the machine, you should understand what they drew, because everything that they are drawing about the machine is in symbols. So you must be conversant. This symbol means resistor, this symbol means trimmer, this symbol means this is the old system, this is the new system, this is the resistor, and this is the trimmer, this is the potentiometer, this is the thermistor, and this is the rheostat. This symbol means this one is popular with us, and this one is LDR. So this is the light dependent resistor, and that is the answer to that question. Whose resistance is light dependent? It is the answer for number 39. Don't forget the symbol. Don't forget these symbols: resistor, trimmer, potentiometer, thermistor, rheostat, and LDR. Don't forget, among them, the most important ones are 1, resistor, 2, potentiometer, 3, rheostat, and thermistor. You mustn't forget their symbols. It's critical and very important. Number 40 now. Now to number 40, to number 40, a wire of cross-sectional area 0.6 millimeter has a resistivity of 7.2 times 10⁻²ohm meter. Calculate the length of the wire which has a resistance of 3 ohms. Now, when you hear the word resistivity, there's only one formula that you need to use. In physics, if they ever ask you for the word resistivity, this is the formula. Resistance R equals E. That's one that looks like E. It's not E. It's resistivity. Length over area. This is the formula that can answer any question in physics on resistivity. R equals EL over A. Where the E is resistivity, the L is my length, my A is area, and my R is resistance. Now let's make the resistivity the subject. No, they say calculate the length. So that means the length must become the subject. So I will cross multiply. RA equals EL, right? Then remove the E from the length. The E will move from here and move under the RA. It now become L equals RA over E. Now substitute A the parameter. What's my resistance in the question? Resistance is 3 ohm. That's 3 times. What's my area? My area is 0.6 millimeter square. 0.6, but it is millimeter. You must turn millimeter to meter, and that's by dividing it by 1000. If you divide by 1000, it is the same thing as 10 raised to the power minus 3. Because minus why? Because you are dividing. And 10 raised to the power 3 because it is 1000 with 3 zeros. Okay, so it is times 10 raised to the power minus 3. That is in meter, not millimeter. So please take note. It must not be in millimeter. It must be in meter. Then over my E. What is my E? My E is my resistivity, which is 7.2 times 10 raised to the power 2 ohm meter. Okay, now my E is 7.2 times 10 raised to the power 2 ohm meter. That's 7.2 times 10 raised to the power minus 2. Actually, there's a mistake in that question. When I checked it, it's meant to be minus 2 and not 2. Okay, because if you work with these two, you won't amount to any of the answers in the option. So it should have been minus 2. Please take note. Then we'll now move on. Then next thing, divide the numbers separately. 3 times 0.6 over 7.2. But take in, I first of all took in 10 to the power minus 2. I took it up. If it goes up, the sign will change from minus to plus. Okay? And then I'll now divide 3 times 0.6 divided by 7.2. Numbers only. 3 times 0.6 is actually going to give me 0.25. Then 10 raised to the power minus 3 times 10 to the power minus 2 is 10 to the power minus 1. So if you now make this is your answer, 0.25 times 10 to the power minus 1. But the last thing is that put it in standard form. So you move the point from here towards here. And then there will be an extra minus 1, making it 2.5 times 10 to the power minus 2 as my length. And that is the answer. I'm making option B the correct answer. Actually, it is 2.5 times 10 to the power minus 2 meter. Okay, and that's the answer for that question. They have 2.5. It should be 2.5 times 10 to the power minus 2 in meter, and that is the perfect answer. So that's number 14. Don't forget that if you learned something from this video and you want more content, click on like button. We have lots of content to send to you that will better help you understand physics. Until we see you again, guys, take care of yourself and bye for now.